Guys, good evening. I'm just trying to find out where the chat window is. Not theatre mode. Ah, there it is, found it. Okay, so tonight's streaming is about wallets, nodes, and staking. So if I have any technical difficulties like sound problems or my internet is a bit slow, just give me a shout in the chat box. So we should just wait another 5 minutes before we get started. Right, checking the chat window. Yes, I'll be going through the wallets. First I'll be going through what a transaction is, how do we use ring signatures within the wallet, and then broadcasting or sending the transaction up to the node, and then take you through to not the actual inner workings of the nodes, but what it does when it gets to the block level where it does the staking. And then we can go through the staking from there. Right, I think we should just start. Okay, let me just find my windows. There we go. Sorry, I haven't done this live streaming at all, so I'm still busy finding my feet here. Right, so hopefully you're going to give me a shout out if nothing works or the windows are not working or something's gone wrong, so I can just reiterate myself and pick off where I left off. So on the wallet side, a lot has changed in terms of getting rid of some old code, going through over to Monero ring signatures, or let's just call them ring signatures. So we've done away with redemption keys and sending messages to the node. So made less calls to the node side, so that we've got more efficiency on the wallet side, and I've reduced the code quite a lot. So I know I haven't committed any of this code to GitHub, but it will be there soon. So we can have a look at the code live in the GitHub repository. But for now, I'm just doing end-to-end testing. So making sure that everything is tied up, the node responds well, the wallet's doing what it's supposed to be doing, and then obviously keeping your balance, because we don't want to lose anybody's money, right? So, okay. At the moment, we're looking at a wallet transfer command, and this is just a mock override. Okay, someone just told me I need to put up my mic, so I guess I'll have to move in closer, right? How's that for you? Sound good? No good? Yes? No? Alright, cool. Okay. Yeah, so we're going to do Docker support when we're ready with the node and the wallet code. What I'll do is it's going to be issued into NuGet packages, so that will be tightly integrated with Docker and how everything works, and we can just run it with a one-line command. Sorry, that was me. I got too many cables lying around here, so I've just pulled the camera out. Radio, should we get going again? Okay, so let's get started. Right, so basically we're looking at just a wallet transfer, and what it does is it creates a session, and a session is only there for when you want to do asynchronous calls into the wallet, so you can have a single instance of the node, and you can use it multiple times across multiple cores, so it keeps the session going. So we've got concurrency. So so this line of code over here is basically just putting the wallet transaction together, and it needs to have the balance of fee and the payments, and the FRM key is just there just for when we're creating a south address. Don't worry about that now. So what it will do is we'll create a transaction. So I'll just run the wallet now. So I'm just waiting for the compiler to start, and then I'm going to do is I'm going to flip windows. You don't see the windows. I'm just going to get some a wallet ID, or maybe we should just create a wallet from scratch. Okay, let's do that rather. Right. I see you guys are asking questions. I think we should wait until we're at the end of the live stream to go through all the questions. I think that would be a better way, so I can just focus on the code and get everything done through, and then we can, well, I'll have my mind back together and I can actually ask questions in a more, for me to, well, anyway, we'll get there. Cool. Roger Rabbits. I like that. Yeah. Right, and another thing, the video will be recorded, so it will be there, so we can have it hanging around. I don't know what Twitch does with it, but it will be there. Cool. Right, so here we go. So we now in the console application of the wallets, and some of you will have noticed it's still the same. There are a couple of new command lines that we've put in, or I've put in. One is a mnemonic two-factor seed, and we'll go through the various things later, how it gets used and how it gets stored, but for now we can just run through a little mock transaction and we can go through ring signatures and how it actually gets put together. What else is there? So yeah, that's about it. So I'm gonna create a new wallet. It's going to ask you, do you want to put in your default mnemonic or passphrase? I'll just say yes for default settings, otherwise you can create it yourself. So what will happen is so we have the wallet path where it where it stores the wallet. We have the wallet ID. It's the same as previously. The two new things that have been added is the seed phrase and the two-factor. So the seed phrase is basically it's a BIP32 that stores it on a path, and then we can do iterations on that path. So you can obviously get your password back or your keys for your wallets. So it's deterministic. The two factors there is just part of the end Bitcoin library again. So it's just for extra security. So you would use it as your passphrase to get into the wallet or make a transaction. So that's the key that you'll be using when you interact with the wallets. The seed phrase is there when you keep it for later. You want to restore your wallet for any various reasons or whatever. You'll be able to do that there. Okay, so I'm going to create a transaction quickly. Right. I'm not going to use that. I've got my own one. Well, I could probably just use it, but it doesn't matter. I'm flipping through windows and you can't see them, so just a second. So I'm going to put in my identifier, my seed phrase, or my two-factor authentication. My to address is the stealth address, which I've already created previously. Now that looks like a long ass address. Yes, it is, because it's got two public keys stored into one base 60 base 58 encoded string, or so it basically enables us to do unlinkable transactions or anonymous transactions using stealth addresses. So the receiver is not linked to the sender, so I can just pay on an anonymous key or public key, as they put it. So I'm just going to put in 1 because it's not real. I'm sidestepping the wallet logic, so I'm just going to create a transaction so we can hit the ring signature setup. Just want to see if it's there. Okay. Okay, so we just now braked, and I'm going to step into the code quickly, and there we go. So what it's doing is it's taking the session that I created earlier. So there will be a session for every identifier and passphrase that you use, so that you can retrieve that session and you can carry on if you running in a concurrency environment where you have more than one processor accessing the wallet. So it's multi-use, if you want to call it that. Okay, So looking at the code over here, we're just going to step through it quickly. Some of it I'll go through step by step, some of it is just I'll go through it like very high level. Okay, so the last known row sums the value. So basically what happens is ML slag has the index of your outputs, and then it will know when it goes through the backend or the library that it needs to use those particular rows from that column, and then it will then sum the total. So when you push it through the verification step, it will then verify to see that you're actually using the ring signature. What's the word for it? Confidential transaction. There you go. Sorry, I stuck my mind. And then the n columns is the ring size. That will be the members within the ring. So I'll be n of 17. I could be number 5 or 6 or number 10, and the rest of the remaining public keys will be used to create cover for myself. So at the moment, we've got a default set to 17, so we're just going to keep it like that, and it's going to generate me an index. So that index is for me, and that's where my output will be sitting. Okay, so all of this code that's going to jump through here is just going to go through to the blind switch. It works out your change from your balance and your payment and your fee. I can't hover over anything so that you can see it. So we're just going to blind switch it so that I can do sums later on, so that I don't have to have any bindings or blinding secret keys on the node side. So if I do a blind switch, I can do straight calculations on the commitments that you've put together within the wallet. So I've done a switch. This over here, when we're going into the M method, this is where the little secret source of the ring signature gets used, and it will place my output that I'm trying to spend, and it will create cover for my public key amongst many n public keys. At the moment there's only 17. So as we saw earlier, we've got where my index was sitting. So if I run my code over here, it's going to drop into the index. So my index at the moment is 0. So my randomization from my n to 17 ring members or mix size, it's now chosen 17 for me, 0 for me, and it will then put it together so that I can add it to the list of public keys. We don't need to see how it's going to do that, but what we can do is just jump ahead to prepare. So from this point, it's now put together all the ring members or the public keys. So if I take my M value, now, and I'll show you what it does. Let's just clear this quickly. Ooh, wrong one. Sorry, that's not going to work. That's copied the old line. So I'm just going to show you what's inside there. And I want to go to Vitex. Let's do that. So it's one long hash string that it is broken up into 33 sections, which are the public keys for your ring members. So that's basically what you're going to pass around to the node. There's actually more information that goes from there to the node. So your transaction is quite big. At the moment it's about 9 KB, but when I serialize it to using protobuf, it actually goes to about 4.5. So across the wire it's 4.5. On disk it's on your wallet side it's a bit bigger, but when I store it on the node side, it will be 4.5. So it will shrink. So it's now going to do prepared. It's going to try and see if you've put everything together, how many PC commitments in and outs and your blinds as you're putting up. It's creating a blind sum so that it can do the calculation for the confidential transaction. It's going to generate it. From the generation, it's going to give you your key image, which is basically just your unique key for that output specifically, so that you can only spend it once. And if it appears on the blockchain more than once, then obviously you're trying to spend the same output. And if you try and respend that output, it will reveal your secret key. So anything that you've actually signed with that output that you're trying to spend, it will then reveal all those other transactions on the blockchain. So you actually, you're screwing yourself. So if you try and do that. So it will go through the verification stage, and it's going to see, yes, everything's right. So we don't need to do this on the wallet side. Obviously doing this for brevity, so that we don't, you don't, how would I say this? I'm just doing the verification up front, so that when it goes to the node, that everything is fine. But we're going to do it again on the node side. So at the moment, I'm taking what you've put together, so that would be the your change, your fee, and your payment, so that everything collates together and it's all happy, right? It will do the commits, it will do a commit sum, it will do a verification on that sum. It will go through a bulletproof, so that it will take the change, what you've put on there, and then it takes the blind sum change that it's put together from the blind sum at the top there, and then it will then use that to actually create the bulletproof. So when we send it across as the transaction and it gets onto the node side, it will then verify to say that yes, you're not trying to cheat or you're trying to go to zero. So everything equals zero, right? So currently now we're creating south addresses for the receiver. That is the address that I used. This is the to address over here at the bottom. I'm going to obviously have my own one because this is my wallet, and I need to marry up which one I want to use to send the fee and the change back to me, right? So here we'll go into creating the fee. We have the lock time fee. Basically that means this is the 21-hour rule, and the reason why we're doing this for a fee, and the fee isn't something that you're going to give to a node or node operator. The fee is just purely there so that you're paying your way forward on the network. This is just to reduce any spam that the network can endure. So we're just trying to slow everything down. You will get it back in 21 hours, and that will come back to you on a stealth address. So there's no linkability from where you actually sent it from. So everything is private, unlinkable. It's all good, right? Okay. Sorry, I'm just checking the chat window out. Maybe I'm missing something. Okay, we're good. So here we're going to put the transaction together, and I'm not going to step through it, but what I'll do is I'll step through the last little bit at the bottom, which will be the V out over here. So the first one within the array is obviously the fee. This line over here is this is coming from the staking side from the node, but when it's on the wallet, it's obviously going to do coin type is fee, and then we have a lock timeout with a script that is using BIP65 for the Bitcoin protocol. So I'm busy mixing and matching some Bitcoin protocol levels into my my transaction that I put together, because I don't want to reinvent the wheel. So as we go down here, so if we, at the moment I can't actually show you the window, but what I can do is I've copied and pasted a transaction earlier so we can actually look at the JSON that's going to get sent over to the node. So I'm just going to quickly switch windows. Right, here we go. Right, so we're on the window that I've copied and pasted earlier, so it's nicely formatted. You can actually see what's going to the node. So your VN is actually the output that you're spending, right? That could be either the fee, it could be the reward from the staking. It can be the change or a payment that you receive that you're going to actually spend, right? So these offsets over here are a collation or a sum of all the commitments that you actually referring to within the ring signature, because you need a way to work it backwards. So you have a prepared statement with the ring signature protocol. You have a generator and you have a verifier, but you still need to know exactly what commitments these ring members or public keys that you're using within the ring signature refers to. So that would be the key offsets. And I know from Monera's 0 to Monero paper, they do mention the offsets, and they have this way of calculating offsets that are a bit smaller than mine. I'm just referring mine to as 33 bytes commitments basically. So I'm just putting it in there. It works. We will obviously optimize and go back and refactor, but for now it works. Okay. So the next line over here is the output. This is for you. Well, not entirely for you. What will happen is, what it's meant for is the fee. The payment is the second one over here, and then this is the change. Now we've got a couple of attributes over here. C is basically the actual commitment. So that is the blinding that you add into the commitment with the value. The E is the return address that you're going to get back onto your stealth address, stealth payment. That would be the view key, right? Or as Bitcoin refers to it as the scan key. N is the encryption. Is the encryption that you put the envelope together with the amounts, obviously, of the commitments, and the blinding, and whatever else you want to put in there, like the memo field, like you're going to say to the guy, I've paid you X amount of whatever, right? So you're going to put in there, and it obviously has a limited size limited. The P is the actual public key, or let's call it the stealth key, and it's I'm using Bitcoin scripting to refer back to these keys and put them together to get the payment from the stealth address, and using the scan key, or in Monero's terminology they say the view key, right? The unlink is basically just a timestamp. Okay, that's the 21 hours, so that you can't spend a fee. If it's under the 21 hours, you can't use it. If it's over, then fine, you can do it. Then you've got the script. The script relates to the time lock. Okay. Signature is null. I'm going to take it out. It doesn't really need to be there. So they all follow the same sort of principle of how they get put together. The V output would change slightly if you're using a Coinbase transaction or a CoinStake transaction, which we'll get to in a little while. And then right at the bottom here is your ring signature. Your M is basically all the public keys that you're using as the member, as your members for cover, including yours. The P and the S and the I is, well, let's say the P and the S is just more information about the ring signature, and the I is the key image, right? Okay, so that basically explains how the transaction works, and we can obviously, make it neater and clean it up more and add more stuff to it when we go along. I'm gonna just quickly check to see why my power is not charging my laptop, so I'm just gonna quickly take my headphones off. I'm just gonna pop around the desk quickly. Right, it was plugged out, sorry about that. I got power, otherwise I won't be broadcasting. Right, okay, so that explains the transaction, and I'm just going to quickly flip over to the code side again, the wallet. Right, so here we go. Okay, so I have a right, okay, so I know some of you are probably looking at this. This is just a crude implementation of what the fee is, and it basically relates to 5 cents, or 5 cents if you look at it in US dollar term cents. At the moment, I didn't have any way of putting the fee together, so I just thought, what, fuck it, I'm just going to do that and we'll come back to it. But it works. So when it goes from the wallet to the node's actually looking at the same piece of code and going like, okay, you need to have this. If you don't, then we're going to fail it. So we'll come back to it. Okay, so at the current moment, it's going to go to the node side. I've got the wrong address here, so I'm just going to go and see if I can fix it quickly before I send the transaction over. So I'm just going to flip over to a new window, which is the node. Right, and here we go. Okay, so we're looking at node code. Okay, we'll get all to this. No. I've got to go and set it up in the app settings. Or is it the app settings? Right, so I'm just trying to find out where exactly I've got to put it. Otherwise I've got to restart the wallet. I'll just do it here. Okay, so I'm just making sure that when this node starts up, it's going to start up on that address. I was trying to get the URL quickly. Okay. There we go, I'll just save that. Right, so what I'm trying to do is I'm going to do some breakpoints just to show you that it is actually going to the node. I have been working on this, so if it falls over for any chance, we can just continue on, and I'll explain the code side of it in terms of the staking and what your wallet setup would be. So I'm just trying to find out my place where exactly I need to put the breakpoint. Not that one. Sorry. Let me just go here. Not that one either. Okay, here we go. There's so much code going on here, I don't even know what the fuck's going. I'm kidding. It's just there's a lot to think of, you know, when you start writing a whole lot of stuff, and you got to think about what's happening in the background. And anyway, enough of that. So I'm going to start this up. Right, so just waiting for the compiler here at the bottom to start up. Hopefully everything's still working. I've realized when I'm running this recording studio software, it eats my processor. So I'm just checking some windows here quickly. Yeah, so just looking at the chat window. Right, chain link. Okay, we can go through all the questions asked. Sorry, I don't have two screens, so I have to flip through screens to actually check the chat out. Oh, look at all that! Look at that! Look at that! It's all starting up. It's all good. Let me just make this bigger for us to see. Right, so the nodes basically started up. So let me just find my place here quickly. Right, we have sockets that will listen to mempools, and we have sockets for listening to block headers. And at the bottom of here is the surf agent that acts as the gossip protocol. Okay, so if we look at the setup in the config, let me just try and get that fucking window, because sorry, I'm just trying to get to the window and I can't seem to where the fuck it is. I'll just make it smaller. Alright, so basically over here is where you set up your seed nodes. You can have none, or you can have n of n, whatever, how many nodes are on the network, and Surf will basically just handle everything for you. The cool thing about Surf is that I can attach tags that relate to the node. So if I look at the code that puts the surf is, so in the tags of surf, and I can have this broadcasted to all the nodes on the network. I can have the ports over here. I can have the block header ports. I have the public key of the node, and surf will basically keep it together and pass it to all the nodes. So when I have another node running, I can actually query those tags for that node, or I have that information available to me, so I can actually see how many nodes are joining, what keys they're using, and what ports that you've chosen. I mean, you don't have to use the default ports, but that's really cool. I like that. It's really small. I think it's 15, 5. Yeah, it's a packet size. So, okay. Right. So if we go back to our window. Right. So it will try and do bootstrap the nodes together, and it's now trying to run the staking. if you're part of the staking at the moment, this node's obviously part of the staking, but it will now listen for any broadcasts from wallets from other nodes in the network, and it will do its thing. Right, so let's just see if that's going to catch my little transaction that I want to send over from the wallet side. So I'm just going to quickly flip screens again. There we go. I have been doing a whole lot of refactoring and reducing the code on the wallet and on the node side, so if anything breaks, it's my fault. So if it does break, it's not a really big train smash. What we can do is we can go through. Okay, so it didn't go through. So what it will basically do is I just need to flip screens there again. Right. Okay. So all it's going to do is going to try and add the transaction to the node. It has a delivered. Does the transaction exist? If it does, then obviously you reject it. If it doesn't, then add it. It will then check to see if the transaction has already been added for that specific node to the mempool. If it has been added, we'll return it back. If it hasn't been added, then we're gonna add it to the mempool, right? From that, it's just basically gonna add a interpret class, so that I can have the node around and the actual transaction that you're sending from the wallet side. So basically what that does is just make sure that everything's in line. It will go through Blockmania. It will set up staging events, so that it will re-listen to any broadcasts from any nodes that are sending the same transaction, so that it can send it through Blockmania. So if I can just find the ledger, the mempool is, so from the controller side to the mempool, which is where the transaction will hang around and try and broadcast it to the network, and this is where the block DAG comes into play. This is Blockmania DAG architecture that will see how many nodes have that actual transaction, who's seen what, have I seen all your scenes, have you seen all my scenes, and if that is the case, then it will drop through to interpret it. That's when Blockmania decides, okay, I have enough information or enough data to actually come to consensus. So that will be the practical Byzantine fault tolerance mechanism that will put it together, but it works on a DAG principle. So from there, it will just go through the mempool. It will send it through to staging side. This is setting up Blockmania basically, so it's looking to see if the graph is running. If it's not, then it instantiates it. It looks to see what the last interpreted was. It goes through a whole mechanism, and then it will set up a delegate listener, so that when Blockmania comes to consensus, that it will just feed it back to that block interpreter. This code basically just looks at the mempool. Has it been added? Is it included? Has it replied? It will then go to staging after that, and the staging is basically just different states of how the staging transaction is working for that specific transaction that we are broadcasting together as a network or a cluster. So when it comes to consensus, it will then converge in one place, and it will drop through to that block mania listener, and then it will then go through to the validator, or if you're a staker, it will go through the POS mining. It just verifies signatures over here, and when it's ready and done, it will come through to block mania listener. Okay, so when it's ready, all the nodes have seen it that have received that specific transaction on the network. This all happens within 4 seconds. The heavy lifting hasn't happened yet, so there is verification, but it hasn't checked the ring signatures or the members, or are you trying to do a double spend. It's just receiving a transaction. It's trying to see that the rules have been applied. Is it valid? There will be more spam protection against nodes, between nodes. At the moment there isn't any, so I'm relying that you being all honest in the network, which is a bad approach anyway. So, but for now, for testnet, it will work, right? As we go along, I'll be updating a whole lot of stuff which I have in my backlog. So from this side, it will come in through Blockmania. It will come into interpreted. It will try and see if it's been added. It will do verifications of signatures. It will create an interpreted storage proto that can be stored in Microsoft faster, which is a nice key value store from Microsoft itself. I like the way it works. It's pretty easy to use it, and I obviously need to have a look at the way it stores because it takes snapshots, or you can do roll-ups. Roll-ups are faster, but it requires more storage space, where snapshots is slightly a bit slower, but it has less space. But we'll get to all of that once we get everything running. Right, so when it's all happy, it will just store it into an interpreted table or a key value pair. And then if you are a staker at that point, if you're not a staker and you're just a node propagator, so all will happen is it will take that interpreted block and it will just broadcast it to the network, or it will take the last known block header and just broadcast it if it hasn't broadcasted it. But if you're a staker and you're going into POS minting, you'll be using this class, and this is where all the magic happens. Right. Okay, so I'm not going to go in depth of how actually it works, but what happens is every 10 seconds there's a timer that runs, and obviously you've got to be in sync and all of that. It will check to see if you've got a coin stake timestamp, and if it's not within that time range, it's going to kick you out. If you are, well, good luck. Let's see if you can get through the next round, right? So the next round will be to include the transactions. In including transactions, basically verifies the transactions, make sure that the ring signature is correct, making sure that you've got all the commitments for that offsets that you can pre-prepare back onto the ring signature, and it all fits together, and you're not trying to do a double spend. So once it obviously succeeds through that, at the moment I've only got 100 blocks or 100 transactions that I actually process. This can be dynamically geared through the config. At the moment I've just set it as 100. So that would be 100 transactions per second to finality, I suppose, if you want to put it look at it that way. So so because of the blocks, or let's say the transaction size, they're a bit bigger, so I have to calculate how big the block size can be for it to be comfortably broadcasted over to the network. So we could have a penalization on the fee or the reward that you've obtained, just like Monero does. So their block size is dynamic. We can put that in later. So plus if we go over to compacted ring signatures, the size will then obviously be smaller than the MR slag ring signature. So once that goes through and it's all happy, it now then adds all those transactions within the block header, and then it's going to go like, okay, so this is where the game starts. so the pos, okay, works on a verified random function, okay, and this is the uniqueness, the randomness that you're trying to create, and the reason why I say that every node on the network will have a different answer is because of this private key, okay, and every node has their own private key, and this is why we get to a different answer for every node that's running on the network, and it'll never be the same. Although we're passing the hash, and the hash is basically the makeup of all the transactions within the block, but you are using your private key to create this the signature, okay. So you then verify the randomness or the proof, and then you say, okay, you're going to pass that into, you're going to go and create a solution for your little puzzle that you need to put together, so you can win the reward and put that into a wallet. So if we just look at what solution is, I'm just going to close Windows there quickly. Sorry, I'm just closing Windows there quickly. Right, so where are you? Is it a task? No, it's a void. No, it's an int. Oh, there we go. No, it's not. Here we go. You're not there. Ah, there we go. Okay. So the solution works off what I call the kernel, and the kernel is the hashes of all the transactions that will go into the block header, and the verified random function is the signature that you produce from your private key, and you create a signature using your public key, and it will be different. Okay. So what happens here is it's going to create a target, and it just takes a big integer, and it takes that byte range, and it creates a really long number, okay, out of that byte array. It will then chuck it through a looping function. It will check to see what the iterations are, and the iterations are it's just an index that counts up. We then create what a weighted target is. So we take the target and we multiply it by the weight, and that weight would be the value of a big integer. So it will just be 1, 2, 3, 4, 5. So it will actually multiply it, and it will get bigger and bigger and bigger. So what we want to do is we want to create a number that's lower than the targets, okay, or the hash targets, which is basically this number over there, and we will get to a solution. And once it compares that weighted target is lower than the hash target, then we've basically created our solution. It's almost like a proof of work. There's different varieties of what's going on here. So if you're looking at a normal straightforward proof of stake, is that you have a balance as a staker, and if your balance is high enough to win the staking round, that's basically what's happened, except that I'm not taking one round. Like if I've got 10,000 Tangram and I want to get into a staking round, I'm gonna go 10,000, and I'm gonna do this multiplication quickly to see if I'm gonna get under the hash target, and if I am, then obviously I've won the round. But I still need to get in there to put my block in. So I looked at this and I thought, you know what, you got to make it fair, right? And this is basically making it fair for everybody. So the guy who's got 20 million Tangram or he's got 1 Tangram is going to be the same result. If you can afford the and I'm not saying someone's got 20 million Tangram, just using it as an example. If you've got 20 million Tangram and you want the reward, you're going to work harder than the guy that has to prove that has only 1 Tangram. Okay. So once we've got the solution, then I calculate what the network share for that solution is. So the network share is basically the remaining total supply, which is going to be used for the staking, which is let's call it 119 million Tangram that you'll be using for node operators. So you'll have a running total, and you've got the total, and I will work out the network share from that solution. Right. So it's very simple mathematics. There's nothing to it. It all works. It's all verifiable. There's no trickery to it. I wanted to make this straightforward as possible. Okay, so so the running distribution total is the total amount that gets decreased every time a node wins a reward, and it adds it to the block, right? So it's just trying to get the total percentage from that distribution, okay, and from there it's just going to go solution times the total percentage divided by the distribution, okay, and that's going to give you your network share. So your solution basically tells the network how much share you got in percentage wise. So that's what I'm trying to achieve there. Then from the network share parts, it's going to work out the reward. The reward is it's right here somewhere. Oh, there we go. So your reward then gets your decrease from the running distribution total. So it just takes the network share with the solution, and it just takes the money off basically, and then I just truncate it. If there's any remaining bits at the end, I just say it's one number. So that's basically what it does. It just truncates it, and then it converts it to a millionth, I think. Yeah. So, and then your difficulty is the amount of Tangram that you're getting out of this whole song and dance that you've participated to see if you win the block reward, right? So the difficulty is a number that you're going to use as the fee, or you call it the reward, but you're also going to use that difficulty to go through what's called a verified delayed function. So the verified delayed function is a sequential function that basically slows everything down. It's not like a proof of work where it's all can run in parallel. So to do the calculation is sequential. Okay, so I'll just trying to slow everything down. So we can obviously tweak all these numbers at the moment. I've just worked it out to 0.0, whatever the network share is divided by 100 is going to give me the solution or the difficulty. So we can work it out, but it works pretty smooth. So the bits is basically what you're going to use to feed through the verified delayed function. So this is the sequential, sort of like the proof of work that you need to do, and it's not a lot. It's basically whatever your reward is, that's going to be the number of increments or rounds that you're going to be spinning on the processor before you can actually broadcast anything and add it to the block header, or cement it and broadcast it to the network. So I've also skipped one method over there. This is the create coin stake transaction. So what it requires is a bit in the reward. So all it is basically your wallet is sitting on a different computer that you've set up, and it's listening for commands from your Node wallet, and you set it up. At the moment it's out in the clear, and we'll have a mini vault where you can store all your secrets. Here you're going to tell the thingy, are you part of the staking, yes or no, and then you go to wallet settings, and you will say you identify your passphrase, your address that you'll be using, which is your self address. We can have a change payment method, so you don't want the payment to go to an address that's sitting on this self address. You can have an option to send the payment wherever you want. So you can have we can get to that later, but this will be the address that it's going to pay it on, and it's not that address, obviously it's a start address. It will be a shorter 33 byte address, and then your URL for your wallets, and then the API REST API receiving end that will listen to the calls when you push out the transaction. So all it does is it checks to see that you're coming from the node side and everything is great. So it creates a payload. It adds the amount that you're going to be putting in, the credentials from the app.settings, your memo that you're going to put in there. I've just stuffed in there Coinbase transaction or CoinStack transaction, the time and date, and from what node it's coming from, and your public key. And your session type is basically just a CoinStack. It will then go and see if you have the amount of Tangram that you can stake from the algorithm that it's asked you. If it comes back as null, i.e. you don't have the amount, then it really doesn't matter. You will wait until your next turn. So all it does is it goes to the node side, and it will go and run that first method that method that creates the transaction on the wallet side. So it goes in there and it goes, okay, I'm going to create a CoinStack transaction. I need to have this and this and this, and I do the sum. I put it together, compile the transaction. I give it back to the node. The node goes, okay, cool. Did you have the money or not? You can always lie and say you had the money and try and put it into the block header, but the validation comes in through every node. Sorry. Every node does a little check. It does verification. Is it verifiable? Is your reward correct? Is the time it taken to do the verified delayed function, is that correct? So there's no really a way to, as far as I know right now, to try and subvert that in any way, right? So if you didn't succeed, it will just drop through there, and it'll just say that you don't have the money, couldn't create the CoinStack transaction, and the whole thing will run again, right? From that, it's just basically looking at saving the transaction, and has it been seen before, posting it and broadcasting it to the network, and then publishing the block header to all the nodes that are listening, and so everything will keep repeating. So that's basically in a nutshell how everything gets stuck together from the node side. Everything has been reduced in terms of code. I've cleaned it up quite a lot. I've made it simple. The validation side is one little class over here, and all it's asking is, did you do it correctly? Didn't you do it correctly? I tap the database or the backend and say, okay, I'm doing matches between what you've given me. Is it real? Pass it through any cryptography verification, and there you go. So that's from cradle to grave, from wallet to node side, and then obviously back again. I haven't showed you what happens when you do a receive payment, but it's the same thing. You look at a transaction, you grab it, you use your scan key. If it is equal to the return address, then obviously you can see what's inside the encrypted envelope that you sent, and you can put the transaction together, and it pretty much basically works when you send a transaction. So there's no real trickery or hand under the table. Everything's above board. No tricks up my sleeve or anything like that. I'm just testing everything at the moment, making sure that it's working, making sure there's no buffer overflows, there's code vulnerabilities. Obviously there will be, and we will audit, and yes, but I'm trying my utmost best. So when I drop the code, it's ready to go, and we're all good, right? And we're all safe, and so that's me. I will obviously do more of these live streams if you want. I can now take any questions. Well, okay, so if you modify your node to cheat, well, you're going to have to convince all the honest nodes that are on the network that the block that you're adding is the correct block, right? Because this is where all the consensus happens. This is where all the block propagations on the network. Does it actually reference the previous hash? Is the verified delayed function correct? Is is basically all the cryptography that you're adding there is correct? Is the ring signatures correct? So it works on the same principle as of any cryptocurrency, that when you're trying to cheat, it's going to obviously look at all these variety of things and apply these rules before it can make the decision to put this onto the blockchain. But by that time, you've already moved forward. So you're going to have to try and create a side chain, and there is a forking rule that I haven't gone through that basically almost works the same as Bitcoin's, but it works in a proof of stake principle with a little algorithm there. But I'll go through it later, maybe for a later time. So yeah. Right. So I see here from the 100 block, that's just a default number that I've just put in there to compact or put all the transactions together within the block header. So, or all the transactions that will be part of the block, I'll just put it 100 transactions within the block. So if I go 100 times whatever, 4.5 KB, that would be the block size. The processing for the block is per second, obviously. The larger the amount, obviously it reduces by milliseconds. But you got the problem is that when let's say you end up with a 20 meg block, you're going to have to broadcast that 20 meg block across the network. And I'm not saying you can't achieve it, but you're just going to slow things down, But you can do it. So maybe we have this dynamic block size. If you want a bigger block because you want to process more transactions, that's entirely up to you. Then we're going to penalize you with a fee or the reward. Let's call it the reward. Nothing prevents you from running multiple nodes. You'll be actually, if you're running multiple nodes to game staking, because you're going to think you're going to create rewards because you've got more nodes on the network, you're actually going to fight yourself. Because every node gets asked the different question, and only one of them can win, right? So the fastest node gets the reward. So obviously I think well, I actually don't really know, because in terms of performance size, if you've got more nodes in the network, there is obviously what's the word I'm looking for? The equilibrium that breaks down the nice. I don't know what the word is. We'll have to see how many nodes we can actually put on the network and see if it goes faster. But like at the moment, all I want to do now is just get the testnet up and running. We can always play around with it. We can put it through test harness, spin up as many nodes as we can, and let's have a ball and see what breaks and how fast it gets. Does it actually make it slower? You know what I mean? So the proof's in the pudding, right? I'm not making any what's the word? Predictions. All right. I see. Yeah, the fees are okay. So the fees that you pay for on your wallet is just there to safeguard the network, so you don't have someone spamming the network. Okay, because you're going to be paying for your transaction. That's the first thing exchanges, obviously, as far as I know, ask. How do you prevent DOS or DDoS or spam protections? Well, we've got a fee attached to the transaction, and they all smile big and they go like, oh yeah, no, that's great, right? Or they've got a proof of work. So this is basically that. You will, however, get that fee back. I just lock it for 21 hours. So when you put your transactions together, you attach some of your money in that transaction and you're sending it to the network, and the network going like, okay, I can see that you've paid your transaction and I'm going to send it back to you after 21 hours. So you can always collect after that. So if you've got 1,000 tangrams and you want to go and spam the network, you're gonna reduce the side of your money. So you're paying something. Yes, you can wait a while, and then hopefully in over a concession of time you'll collect all your fees back and then start again. But all I want to do is slow you down. You know, I mean, that's what proof of stake does. All it does is slow you down, right? So well, I mean, how fast is a transaction? Is that to finality, as in I send my transaction from my wallet to the node? Because from that to that is really fast. It's milliseconds. Depends on how far you are. It will take 1 second. To let it go hang around into the mempool, that depends on how many nodes are in the cluster and have seen that transaction when it broadcasts it out. I've tested 4 nodes on different machines. Sending my transaction through to one node takes 4 seconds. So yeah, that's just me testing. We're obviously going to have different numbers when we're in the wild. So yeah, I like wearing a beanie. Makes me feel comfortable. C sharp, you know, it's a really robust language. It's really come a long way. You know, it's not as a steep learning curve like Rust or C++. You know, the more people that can actually get into blockchain, the better. You know what I mean? So we can just evolve from what we have. I mean, if you've got Solidity from Ethereum, we're looking at JavaScript, and there's a lot of JavaScript jocks around there. You know, and if you can do JavaScript, you can do Java, and if you can do Java, you can do C sharp. I'm sure you can do C++. Or Rust. But I mean, language is a language. I like it. It's easy. It's pretty good at what it does. Yeah. We are obviously looking at going over to Rust in the future. But for now, I mean, it is what it is. We'll convert it later. Any more? Have I missed anything? Implementing zero knowledge proof of stake. Sorry, I joined late. Yes, it's zero knowledge proof. What makes it zero knowledge proof is it uses stealth addresses and it uses ring signatures. So that's the zero knowledgeness within the proof of stake, and you can spend your reward without linking any transactions from previous transactions. I mean, that's the whole point of it. Right. So we are looking to update the new white paper after testnet. This revision of Tangram it's not like the old Tangram. So we need to probably take out a lot of what's in the white paper currently and put the new mix in what I've put in for testnet 2. So it's going to be on our top priority. So Tuesday, what is Tuesday? There's only how many Tuesdays within this year? 2 more Tuesdays. 2 more. When? Yeah. Yeah, that's great. How are you doing, Pizzy? Okay, so any more questions? Yeah. So I'm gonna jump off, but I'm gonna hang around here for about 5, maybe 10 minutes. See how it goes. So if you want to ask any more questions, I think this thing is already set on self clipping. I haven't blocked anybody to self clip, so you can do it if I didn't think I did it properly. Are you still feeling excited, not burnt out working on Tangram? It's been a rush. It's been a journey. It's been a life-changing experience. Will I do it again? Fuck yes. Let me have some tea. My voice. Right. Okay, so I reckon we can cut it off and have more questions within the Discord or the Telegram. Yes. So hopefully you enjoyed it. Hopefully I showed you everything you wanted to see. It's obviously better to have code within the repo that you can actually start running code and doing the installations. I have been refactoring and doing more optimizations, and I'll get to the how you're going to set up and everything, and those testers that have come forward or in DM, I'll get back to them how we can approach it and take it from there. What do I think people expect from this coin? Well, in the beginning, people wanted fast, they wanted feeless, and they wanted private. So that's what I expect from this coin. I expect those 3 things, actually 4 things, and it's fungible. So this was the whole thing of why we got to do Tangram in the first place. So we wanted to give what people wanted. So oh, and DAG, sorry. Yeah. Otherwise, you guys can expect whatever you want. Uh, right, Roger Rabbit. I'll check you later. See you guys later. Thanks for joining. So I'll push some code. I'll make some more announcements when we're ready, and then we can talk about a whole lot of stuff and updating the roadmaps. But yeah, so far so good. It's looking good. People are asking when is it coming out, so it's definitely going to be end of the year, right? So 2020 is 2020. That's when we're going to drop it. Right, cool. Anyway, so I'm going to stop the recording and see you guys later. I'll see you guys on Discord, and we can set up another live stream later. Check you guys later. Thanks for attending.